Cool, appreciate it, thank you. Yeah, so, I guess, we're just agile, so we do retrospectives at the start, which is kind of cool. You'll also notice how agile we are because we've actually renamed the talk. I think it's called something about climbing in your schedule, but that's okay. So, to do a retrospective, it really helps to know where you're starting off from. So, what we'd like to do to start with is do the boring part, and that is talk a little bit about ourselves because it kind of helps motivate what we saw going forward. So this is my part, and then Bruce gets to do his part. So I actually got into computers fairly young. This is me and my friend Toby Bailey about, where are we now? 45 years ago, I think. So everyone's sitting there going, programming an analog computer, which was kind of fun. If you don't know what an analog computer is, ask your parents. But we had a whole bunch of fun doing like damped sine waves and all sorts of cool stuff with that. And at that time, I was going to go do math, or as we called it, maths, at university. And I decided after this that I was going to go and do software instead. So I went to a local technical college and started programming. We programmed using ASR33s and a 300 baud modem, or as we say, that's 30 characters per second top. We used to program because telephones were expensive to use in the UK, you'd pay for it. So we used to program offline by punching paper tape, and then we'd feed the paper tape back into the system when it was online, and it would run, and then we'd quickly disconnect. If you got in less than a minute, you didn't have to pay for the call. So we were pretty good at that. One of my first programs, we programmed BASIC up on the local council's mainframe, an ICL computer. And we were allowed to store 5 files up on their machine. So the very first, well, not very first, but pretty much the first program I wrote was a BASIC program that would store other BASIC programs inside itself and then extract them out so you could run them. So it was kind of like my first piece of metaprogramming was in BASIC, which is kind of fun. Got my first summer job programming a language called Nickel, which is a bit like RPG, which is a bit like hell. And we were programming it using these kind of hand punches. So you would sit there and you'd punch the cards by using chorded combinations with your fingers, right? You learn not to make mistakes very early on. The compiler we were using is kind of fun. The compiler came in a card deck, and it was about that long, and it had different colors, different color cards. And what you did is you took your program cards and you stick them between the blue and the green, right? You stick your cards in there, and then you feed it into the card reader, and it would all go through the card reader, beginning to end, and then a minute later, the card punch would wake up, and it would punch out some cards. And you would take those cards and you put them between the second and the third sections in the compiler deck and feed it through again. And you'd keep doing that until your program was compiled. It was a multi-pass compiler. Literally, it was fantastic. So we had a whole bunch of fun doing that, and we actually got paid for it, which was rather nice. When I went to college, we graduated from that to this, the old IBM 029 card punch. I got really good at these. And we would take there and we'd punch out a deck of cards, and then we'd take it and we'd put it outside the computer center, and every hour the operators would come and take our card decks and stick them in, and then we'd get the printouts out a bit later on. After a while, I actually got to work inside the center, so I got a job actually helping run the mainframes, and we used to give tours to schools and stuff, and I'm infamous because the old IBM mainframes, the 370 smaller series, were microprogrammed, right? And so when they first start off, they load the microcode into memory, and that then turns them into an IBM 370, and they start executing it in code. And so there's a light on the front that actually had 2 bulbs behind it. It had a white bulb and a red bulb. And when you did it's called the IMPL, the initial microprogram load, you push that button, it goes red, and then as it's loading, it goes pink, and then when it's loaded, it goes white, right? And I was like, I thought it was really cool, and you could pull the button off, and you could see the 2 bulbs, right? So these school parties would come along, and I'd say, and this is the thing that does that, and look how it does it, and I'd pull the thing off, and they'd go, ooh, you just pulled something out of the computer, right? And they'd see the 2 bulbs, and then I'd put it back on again. except the one time I put it on just a little bit too hard, and I hard booted the computer, and I had 30 people in the lab next door all come scream at me because I just lost all of their work. So don't ever hire me to do operations. Please. So I've been one of these people that's always loved languages, computer languages. I'm lousy at human languages, but I've loved computer languages. And I've programmed quite a few. There's some really quite fun ones. Oops, that should be BCPL, not BCP. Sorry about that. One of my favorite on that list is APT. Has anybody ever done any numerical control programming? APT is a really old-fashioned numerical control. You sit there, you write the program, and it produces a paper tape that you feed into a milling machine, and it'll sit there, it'll make the nice shapes for you. And the cool thing is that it's constraint-based. So you can define like control points and say, I want a line between here and here, and then I want to go around here, and it knows about the radius of the tool, and it can adjust the points and everything else. What it cannot do is work out that you're about to cut its own arm off. And so you have to be really, really careful when you're using it, not to actually have the thing backtrack over. But yeah, we all had great fun like carving out our initials in blocks of steel, so that was kind of fun. Does anybody remember Complang MISC? Yay! All the old farts are on this side. Right. So back when computers were computers, we didn't have any of this fancy, sort of web stuff. We had Complang MISC, which was one of the Usenet use groups. And people who published or created languages would post up to Complang MISC and say, hey, I got this brand new language. And you would download the source code to build it. Downloading the source code meant getting 20 or 30 messages that contained the UU-encoded source code and concatenating them all together, then decoding it, and then spending 4 days trying to work out how to get the dependencies right so it would build. Okay. But I used to do that. I used to love doing that. So once, twice a week, I'd be downloading one of these languages, and I would play around with it. And most of the time, I would just throw it away after a little while. But as you'll learn in a second, I came across one that made really a fundamental difference to my life. And I'll talk about that after Bruce has embarrassed himself.
So Dave's section was a little bit more interesting, so I'll make up for that by making mine longer. So,
or maybe it just seems longer.
Yeah, I think Dave's right. So Dave loves languages. I've had a love-hate relationship with languages until very recently. My first programming experience was a birthday present. This puppy was a TRS-80 color computer, 4K of RAM. 4K, right? You had 16 rows of 32 characters across. This baby was tricked out. Didn't even have to buy a monitor. You just plug it into the TV, right? Same thing at our high school, a little bit down level. These were black and white. But I got to tell you, I really loved BASIC. It's not a manly thing to say at a conference like that, but I really loved BASIC, and all good things have to come to an end. I graduated high school and went to Mississippi State for undergrad, University of Texas for graduate work. Mostly we used Pascal. You guys remember the old UCSD Pascal compilers? So Pascal is not a sexy language. It's a very wise language. So I like Pascal. All good things must come to an end. So I graduated from Mississippi State. Went to work at IBM, where I kind of saw in the museum some of the things that Dave's been working on. And so I used mostly the C family of languages, C, C++, and later Java, probably more Java than anything else. And I had a relationship with Java. So after a little while at IBM, you reach a point in your career where you could either, you get that last technical promotion, and you can either shift over to the management track, or you can leave, or just kind of top out at your career. So I decided to leave. I joined a startup, which blew up immediately, right? So I'm in my solo career now. So that's another way of saying consultant, which is another way of saying unemployed with business cards, right? And I still had this love-hate relationship with languages. I wrote books, and even in my books, I had a love-hate relationship with languages, bitter and better, right? This one was first. This actually, at one point, it struck a nerve with people, not based on the content of the book, but based on the title. And so I got slashdotted, and this thing started rising in the Amazon rankings. And for 1 hour, I was between Hawkins and Grisham. Just 1 hour, right? Number 8 on Amazon. Not 8 in computer books, but 8 for all books on Amazon. So that was kind of cool. But this was the better book, and it won a jolt. And so I was kind of feeling full of myself. And I met Dave Thomas at a conference. And we were on a shuttle back to the airport. You remember this shuttle, Dave, in Atlanta?
I do.
Yeah, so I want to formally accuse you for wrecking my Java career.
Hey, you're one of many.
Well played, sir. So we had this conversation, and for those of you who have met Dave, he's a consummate British gentleman, always polite. But I hit him with some pretty aggressive questions, about Java and Ruby, and the answers were not what I expected them to be. So I did what any Southern gentleman would do. I got more aggressive and more belligerent. And finally, I ticked Dave off, which is the only time that I've ever heard it happen before or since. And he said, "Shut up, go do something non-trivial in Ruby, and then we can talk." And that's the piece of advice that wrecked my Java career. This was a book I wrote because I didn't want to code Java anymore, and I didn't believe that I could sell Ruby to a manager. But I believed that at the time, we were writing applications, big, fat web UIs to babysit a relational database over and over. And Ruby could do that, and it could do that very well. And we could train a Ruby developer, a Java developer to write Ruby more quickly than we could train a Java developer on the new Java stuff, right? Which was kind of a scary thing for me. So this quote had another important impact. This word, non-trivial, eventually became an idea that, well, gosh, I kind of see Ruby as this beautiful language to me that I love probably more than I should. And I don't think that this will scale into the architectures and business problems we're going to need to be throwing at it. So I was afraid, and I started coding. I started looking at languages, and I couldn't really see where the future was going. And that was an unusual experience to me. So I just started coding non-trivial problems in different languages. And I thought that my audience might like to share the experience with me. So it was kind of a book that was born by accident. But there was another guy who was having the same doubts about Ruby. And right after I published the book, he picked up the book. I didn't know anything about it at the time. But we were both looking for something different, for some quality that was missing in Ruby that we weren't really finding. It didn't really match the way that we thought in the languages in this book. But of course, you know that this guy's name was José Valem, the creator of Elixir.
Yep, thank you. Cool. All right, so that's history. Now we're going to have a nice bit of soft, touchy-feely stuff, right? So we talk about loving languages, and we talk about being excited by languages, but I mean, how can you do that, right? A language is just a tool. It's just a bit of software. How can you possibly love a language? How can you possibly fall in love with a language? And it's something I think about a lot, because I often say that I do. I often tell people, do things that you love. But, I mean, what does that really mean in terms of technology? And casting around for, some kind of explanation of this, I used to put up pictures of people and say, anybody know who this is, right? And in the old days, it used to be easy. It would be a Guy Steele or something. Now it's like, sort of more and more obscure, and I just don't even bother. So this is Christopher Alexander. And he wrote a number of books on architecture. the one I'm going to reference is called The Timeless Way of Building. He is a darling of the patterns movement. In fact, the entire concept of software patterns comes from him because he created architectural patterns to describe the process by which buildings could be designed. It turns out that the software patterns people totally misunderstood what Alexander was talking about. And there's actually a famous Oopsla, I think 2003, when he actually gives a keynote and basically says, "You're all idiots," which is well worth watching. But he talks about there is a central quality, which is the root criterion of life and spirit in a man. See, I told you it was going to be touchy-feely. A town, a building, or a wilderness. This quality is objective and precise, but it cannot be named. And he's talking here about the things that are important when we're thinking about building something. And this became known as the quality without a name, or as it's commonly abbreviated in the patterns movement, QWAN. All right, Q-W-A-N. What does QWAN actually mean? Well, it kind of means whatever you want it to mean. It's one of these I know it when I see it things. Alexander himself has come to call this completeness, the idea that something is self-contained and wrapped up. This morning, John actually gave a really nice quote, which I just stolen and added into this presentation a few minutes ago. It seems there's a positive correlation between the simplicity of the rules and the quality of the algebra as a description tool. That is that quality without a name. You might even call it the soul of something, right? The essence of something. It's one of those things where you really cannot describe it that easily, but you know it when you see it. For example, which of these two do you say would illustrate that quality? It's a trick question. Most people will go here. But there are some people for whom that holds the quality, and that's perfectly reasonable. But one of them does have a quality the other one doesn't have. Just to be topical here, which of these two would you say had the quality without a name? Well, this guy is cheaper. It's engineered. You can see all the triangles and stuff, so it must be engineered, right? This guy's clearly wasteful. It's like non-optimal structure there. But I think most people would say this is the more elegant, this is the more humane of the two. This is the one that has the quality. Bringing it back around a bit, which has the quality? It depends, but I think probably most people would say this is more expressive, this captures what I want to do. So there is this element of quality without a name, which I could call soul, in just about everything that we use. And I want to talk just quickly about what I think might be this quality in Ruby and in Elixir. And these are just random thoughts, right? So when I first came to Ruby, I downloaded it off Complang MISC, and I put it all together. I got it to compile. It was Ruby 1.4 in 1997, I think. Anyway, and it was actually recognizable as the Ruby we have today. I downloaded it not long ago, and it's, you know, you can still code on it quite nicely. And I fell in love with it. I fell in love with it so much that I downloaded it in the morning, got it working by midday. I was playing in the afternoon. Normally, a language would last about half an hour before I throw it away and get on with my real job. I was still using Ruby that evening. The next day, I called Andy and said, hey, you got to try this. This is pretty cool. And basically, at that point forward, Ruby was my go-to language for small tasks. I loved it. It just worked for me. So let me tell you some of the things that attracted me to it. And these are superficial. There's a whole bunch of other things that people will like. One of the cool things to me is it doesn't have separate compilation phase, right? It's not that it's interpreted. It looks like it's a compiled language, but actually executes code the whole time. So here I can do like useful things, like initialize a constant in a class with code that I execute during compilation. And that could be arbitrarily complex code. So for example, my classic anagram solver builds the list of signatures as a constant, which is kind of nice. Not a big deal, but it just felt nice after I came from C. It's got really nice metaprogramming, which is, I know, a bit controversial in some circles, but for me, again, it was really nice. So here's an example of a web server written in Sinatra. If you're interested, I will take offers and IPO, but it's not exactly phenomenal. You can do cool things with Sinatra. I didn't realize you could do this, but here we can have a web server which is non-deterministic on the URL that you go to. So 1/10 of the time, it will say you won a car, otherwise it will say sorry you lost, which is kind of fun. Ruby also has duck typing, which means that the objects and classes are all open at runtime. So here, for example, I needed a server, a web server or something, that would respond with a 404 during a unit test. And rather than go to all the trouble of going and getting a mock object library or somehow, doing that, I just created an object. In this case, it's a string, and I added the query method to that string that would always return a 404. And then I just passed that string into my application as if it was a regular web server. And it returns the 404 structure. To me, that is just so sweet. Right? It's lovely just being able to do that kind of simple thing. It just means my languages get out of my way and let me do what I want to do. And of course, I don't care. I mean, there are cat people, there are dog people. Right? There are Ruby people, there are Python people. There are people who like one thing, like another thing. That's wonderful. Aesthetics changes, and everybody is different. But I think everybody can have things that trigger warm feelings when you're using something. Let's do the same thing for Elixir, but just really quickly. So here's an example of code that we have all written in C-like languages. And the problem with this code is that explaining it to your grandmother is not trivial. Right? How do you parse it? Well, what you actually have to do is you first of all work out that this is an assignment, so the cool thing is over here. Now we're going to skip forward until we hit the innermost nesting. Right? Yes, Grandma, there is an innermost nesting word. Right? So now we're going to apply this to that, and effectively substitute that there, then apply that to that, and then that to that, and then finally we get our result. It sounds a really trivial syntactic thing. And Elixir is not the only language that has this by a long way. But this idea of being able to pipe the result of one function in as the parameter to the next makes a significant difference. Right? It is not just a syntactic nicety. Because what this does is it changes the way you think about programming. Because once you start writing code in a language such as Elixir or Haskell or whatever else, you are no longer thinking about programs as being objects, as being clumps of data and clumps of functions that work on everything else. No, programming is now nothing more than transformation. All you're doing is transforming stuff. You start at the top, you get to the end, and along the way, you go through all of these nested transformations. But when you're starting off, it's actually quite hard to think about things in terms of transformations. For example, a web application actually is nothing more than a transformation. It takes a request and transforms it into a response. And that sounds glib, but the entire basis of the Phoenix framework is a set of these nested transformations. And the cool thing is you can get yourself injected anywhere you want in that chain. So thinking about things in terms of transformations changes the way I think about programming. So that one simple little operator there changes the way I thought about programming. And that made a big difference to me. Because functions transform data, and that's all we have to do. Now, speaking about functions, you know that Elixir kind of looks a little bit like a C-like language. So, for example, I have like a case statement here. I'm going to open a file, and that's going to return the tuple, either OK or error. And I have to do things depending, right? And suddenly we seem to have lost our functionalness, right? Suddenly we seem to be back in C or Java or whatever else. And increasingly, I'm trying to find myself doing things without writing code this way. I want to write code purely as transformations. And it turns out in Elixir, I can do that. because my case is simply a function. And so here's my file name, I pass it through open, the result comes back. If it matches that, then I'm going to process it, otherwise I'm going to do the report. Again, it's not a major deal. It's not like, earth-shatteringly different, but it does make a difference to the way I think, and the way I code, and the way I perceive the world. Okay, so when we're talking about functions, quick pop quiz. It's kind of helped by the fact we have a syntax highlighter on here. How many keywords are there in this piece of code?
Unique or?
Yeah, unique. Unique, yes, unique. 3, 4, 5. 3, 4, or 5. Well, it depends what you mean. Risk of doing a bill, it depends what you mean by keyword. Arguably there are 0, but at the very most there are 2. And those 2 actually are merely syntactic sugar, and that's do and end. Right? You don't actually need any keywords, because I could have written this as comma do colon and then an expression. Right? So that's all that's doing is it's simply replacing that block as a parameter on a keyword list into the def thing. So actually, technically none, but in terms of the Elixir, 2. And the reason for that is that just about everything in Elixir is defined in Elixir. So this is just from the kernel module. There's a whole bunch of other ones that do this as well, but these are the things that are defined as macros or functions directly in Elixir. So here's our case that we used previously. Def is there. Def module is somewhere. If is over there. All of this lot is defined in Elixir itself. So you can say that the language is the language. The cool thing about that is that all of these things, that means they're all soft. I can redefine them. Yeah? Or I can call them. So if I wanted to generate a method on the fly, I can just call that def macro and pass in the necessary parameters, and it defines a method for me. If I wanted to change the meaning of assignment, or binding, I guess more accurately, if I wanted to change the meaning, I can do that. And in fact, the test framework that comes with Elixir does exactly that. So that when you write a pattern match that fails in an assertion, it actually is going through a altered version of equals, because then I can actually report the left-hand side, the right-hand side, and why they're different. Pretty damn cool. Do you want to go in there and change absolutely all of the syntax of the language? Of course not. This is one of those great power, great responsibility things. Right? But to me, it makes me happy knowing that I can do that. That if I needed to, I can get in there. If I want to write a version of def that actually logs its parameters because I've got some debugging issue, I can do it. And I can do it cleanly using safe macros in the language. It's a small thing, but it makes me comfortable. It makes me kind of fall in love that little bit more. This is really pedestrian, but really important. I love, love, love the fact that in Elixir, I've got great documentation out of the gate. So I've got the Elixir guides, which are a fantastic introduction to the language. Obviously not as good as a certain book, but not a bad introduction to the language. Right. We have documentation on all of the APIs, nice looking with lots of examples. I mean, phenomenal number of examples. If you're inside the shell, you can get help on individual functions. And again, you get the full stuff. It's really fantastic. One last thing that I really like about Elixir is this kind of empathy that I can feel, this kind of love I feel from the team that created it to me as a developer. And one of the cool ways that that's exhibited is this is the suggested template for an Emacs Gen server. Isn't that cool? I can actually scroll inside the slide. I like that. So that's the code. It's 128 lines long, of which 22 lines are code. So, yay documentation. The equivalent code in Elixir would be that. Not a big deal, not slam on Erlang, but the fact that someone said, you know what, it would be really nice if we could take that boilerplate away, because it gets in the way of the code, And so use Gen server actually stubs out all of those methods, but allows me to override them when I need to. So that's an important thing, important idea. Here's an example of agents written on actual Gen server actually using that. And with Elixir, the Quan goes on. All right? There's all sorts of things. Everybody who uses it will have their own list. I don't care. They're just fantastic things that make the language just feel nice, feel good. And so that's why I'm really keen to spread the word about Elixir, because I would like people to feel good when they code. And the important thing is that Quan is two-way. Right? We are inspired in the presence of quality. We behave differently in the presence of quality. We will treat this building way better than we'd treat some rundown warehouse room, because we respect it. So in Elixir, pipelines and protocols inspire us to code in terms of transformations. Behaviors and macros inspire us to code in the domain and not in the implementation. Great documentation inspires us to write more than code. And by doing that, it makes us think about the code that we're writing a little bit more. Modularity and the release manager inspires to write tiny apps and deploy more often. And great leaders inspire us to emulate them. But this is difficult.
So this is Mount Everest. It's over 8,000 meters. It's hard. Climbing this is not the hardest mountain in the world to climb, but it's close. It wasn't summited until the first time until 1953 by this man, the guy on the left for you, Sir Edmund Hillary. And I want to make a suggestion that mountain climbers and language makers are in some ways the same. Language making at its core is seeking Quan. If you think about it, a language maker provides a way to do something that you could do before you had the language. But the improvements in the experience are sometimes hard to quantify. Language making is also hard. Nobody is going to just mount an assault on, only the most elite climbers can just mount an assault and fly up Mount Everest. The problem is that there's this thing at the top called the death zone, and that's the area over 8,000 feet. And over 8,000 feet, you've got about 30% of the air that you do down at sea level, and that makes the brain do crazy things. And most of the deaths on Everest happen over that line. And what that means is that rather than racing to the top, you have to establish a lot of intermediate camps, and the logistics kill you, right? And so the same thing happens when you're creating a language. You're not just building a language, you're building also the ecosystem. You have to bring the individual users along. Language making is also messy. On Everest, it's becoming famous that the places that people go have a lot of garbage. Have water bottles, they have oxygen bottles, any kind of trash that you can imagine. Language makers often experience the fact that some of the aspects of creating the language are messy. Sometimes you have to say no, and some people don't respond to the word no the way that you might expect them to. I recently got to spend some time with Jose in Poland, and we were on a train, and we were talking about productivity, and he was asking me, Bruce, how does Elixir make your life more productive? And I told him, and I asked him, what makes you more productive? And he said, Well, I'd like to answer that question a little differently. I'd like to talk about what makes me not as productive. And the answer really surprised me. He said, you know, we have a great technical team. I spend a lot of time with Chris McCord on Phoenix. I spend a lot of time with James Fisher on OTP. We've got a great technical team. The hard thing is when some people respond in hostile ways to this thing that I built. That brings me down, and I find it hard to code as fast. And I thought about it, and I'm very much the same way, and I bet you guys are too. But language making is sometimes a messy endeavor. So with all of these things stacked up against a climber or a language maker, how do you ever reach the top? You use Sherpas, of course. So Sherpas are an ethnic group living near the border between Nepal and Tibet. They live at a higher altitude, and they can function higher on Everest. They can do things high on Everest that we would struggle to do at sea level. And I want to talk about a few of those things. The Sherpas help build camps. The base camp at the bottom, and the intermediate camps that go up the mountain. What happens is that when you're climbing Everest, all but the most elite climbers, they have to climb up higher to acclimate themselves, and then down lower to actually let their bodies recover. So the Sherpas are the ones that make the camp. And in fact, we experience the base camps every day that Joe Armstrong and Robert and Mike created in the form of the Erlang language. That's more than just a base camp for our day-to-day jobs. It formed the foundation for a lot of the messaging traffic in the world, for a lot of the world's economy with the acquisition of the WhatsApp and all of the software that's built on top. But it also built the foundation for Elixir. So this is the early commit story for the Elixir programming language. And I would argue that this period right here represents José's great decision. So, Chris, do you remember what he called this period of like helplessness when not many commits were happening? Yeah. So we witnessed a keynote together in Austin. He said I called this the Valley of Despair. I was trying to build a language myself that was on the beam, right? And the beam was going to be everything that he needed to establish this new language. But after thinking about it, he said, no, that's not enough. I need to carry a lot of the Erlang goodness with me. It needs to be 100% compatible. We need OTP. We need the concurrency constructs and the concurrency story. I also need to lean on other communities as well, like the Clojure community that enables the metaprogramming, that enables the macro, that enable Elixir to be built in the language itself. José's great decision happened right here. And then you saw Elixir explode, and the commits never back off to that level again. Sherpas carry the heaviest loads. Hey, what do you need? I need somebody to bring a kitchen up to base camp. Well, I'll take the 2 water basins and the chimney, and my friend here will carry the cast iron stove. How many do you need? Just 2, right? Sherpas carry the heaviest loads. So there was a time when I decided to build, to actually commit to Elixir for my company. There wasn't a web server yet. And my boss asked me, hey, what web server do you want to use? I said, well, there's not one that exists yet. And then he said, well, okay, so we can't use Elixir, right? I said, no, I have a plan. So José had this thing called Dynamo, but it was very clear that that was too much of a load for one person. You can't build a language and a web server at the same time, not even if you're José. So I said, look, this is madness. He said, I don't have anybody that I can lean on to build a web server. I said, okay, that's okay. Let's build a web server kit. Let's build a Lego kit so that somebody else can come along and build the web server. He said, who's going to build that? I said, I don't know. Let's go fishing. And we caught a Sherper, Chris McCord back here, that built Phoenix using that framework. Sherpas prepared the way. This is the Kumbu Icefall, and that's the most imposing barrier on the path up to, and the southern route up to Everest. Sometimes there are chasms that are too wide for us, right? Like the chasm between Phoenix and Elm, the keynote that you saw. We need a Sherpa that understands better than we do to help bridge the gap between the areas. Right? So you guys might be looking at me and saying, Bruce, I'm really, really uncomfortable with this analogy. I know the history of Sherpas, and Mount Everest has been climbed on the back of an oppressed people. I'm not saying to climb on the back of an oppressed people. What I'm saying is that we are all Sherpas. This is our ecosystem. You can write a test. You can write code. You can start a conference. You can tell other people what you saw at this conference. We are all Sherpas, and we define what happens in this ecosystem. Everything that you do affects what's going to happen with the people that come after you. But we can share the load. Not because we have to, but because we're blessed.
And that should make you happy. And that's what languages should do.
Any questions?
Stunned. They are stunned.
So let me set something up that we probably should have set up at the beginning. So it's really, this is a great moment for me to be able to share the stage with Dave. And the reason is that he's got a sense of Quan, and he's able to see it before the rest of us can. And the reason that we should listen to him in this context is that he kind of discovered, he was the first one to see what was happening with Ruby, and wrote the Pickaxe book and helped write the book for the web servers, and also noticed what was happening with the Phoenix language. And that's kind of why this talk was put together, so that we could kind of see, from the perspective of a user in the community, and from the perspective of somebody who's actually identified what's happening early before the explosion of the second language. Yeah?
Just a comment. Until you said this, I didn't know you were a fan of Christopher Alexander. And I met Ralph Johnson, who began at 4, and he met a lot of programming language designers, and he asked me which of Alexander's books I liked most. Did I like the pattern language, or did I like the Timeless Way of Building? And I instantly replied, the Timeless Way of Building. And he said, all programming language designers say that.
I can believe that.
I thought it was cool.
Yeah.
Really interesting.
And it's true, isn't it? If you haven't read it, read it. It's one of the, it's amazing.
Any other questions?
Cool.
Okay, that's all we've got. Thank you so very much.
Thank you.